Hello friends, welcome to the sixth video in this series of videos on Introduction to Swift. In this video, we will learn about classes, properties, methods, subscripts, and inheritance in Swift programming. Classes. Classes in Swift are building blocks of flexible construct. User can define class properties and methods. Swift allows us to create classes as a single file, and the external interfaces will be created by default once the classes are initialized. Inheritance acquires the properties of one class to another. Properties are defined to store values and methods to improve functionality. Initial states are defined by initializers and subscripts are used for providing access to values. Class is defined by using class keyword. This, for example, is syntax for defining a class. Class properties and methods are accessed using dot syntax. Class in Swift means multiple constants and variables, that is properties, pointing to a single instance. Class instances are always passed by reference. Identity operators are used to check the equality of two instances. For example, here we have defined a class called employee. We have name, email ID, and extension as properties of this class. Initializer is defined as shown to initialize all the values of the properties in this class. Now we can make an instance of this class called employee1. We can refer to email ID of this instance by using dot syntax. That is, access email ID by using instance, that is employee1 dot property name, that is email ID as shown. To check identity operators, we have made one more instance of this employee class called employee2. Now we check if employee1 and employee2 are referring to same instance or not by using identity operators as shown. So as you can see, we will get both employees are not same because they are the employee1 and employee2 are two different instances. Now if we refer to employee1 by using a different reference, that is employee3 equals to employee1, and then try to check equality by using identity operator, we get that both are referring to the same instance. Classes and structures in Swift have many things in common. For example, both can define properties to store values, methods to provide functionality, subscripts to provide access to their values using subscript syntax, initializers to set up their initial values. Both can be extended to expand their functionality beyond a default implementation. Both conform to protocols to provide standard functionality of a certain kind. Classes have additional capabilities that structures do not. For example, inheritance. It enables one class to inherit the characteristics of another class. Typecasting, which enables us to check the type of a class instance at runtime. Deinitializers, which enable an instance of a class to free up any resources it has assigned. Reference counting allows more than one reference to a class instance. Properties. Swift provides properties for class enumeration and structures. Properties can be classified as stored properties or computed properties. Both types of properties are associated with instance type. Stored properties. These properties are used to store instances of constants and variables. During definition, stored properties provide default value, and during initialization, user can initialize or modify the initial values. For example, here digit and pi both are stored properties. Pi is already initialized to a value at the time of definition, and digit's value is set at the time of initialization as shown. In this case, digits is a variable stored property and can thus be modified after initialization like this. But pi is a constant stored property, thus cannot be modified. Lazy stored properties. Lazy properties are used to delay object creation by creating properties that are dependent on other parts of the class that are not yet known. Lazy modifier is used before the variable declaration to make a stored property lazy. For example, in this case, num variable is a lazy property of type number. Number is a different class which is not known at the time of initialization of this property in sample class. We can access the prop variable of number class from an instance of sample class by using dot syntax as shown. Computed properties. These properties provide a getter and setter to retrieve and set properties respectively. They do not actually store a value. A computed property with a getter but no setter is known as read-only computed property. A read-only computed property always returns a value and can be accessed through dot syntax. You must declare computed properties as variable properties because their value is not fixed. For example, here we have defined a class called sample1 with properties number 1, number 2, length, breadth, and middle. Middle is provided with getter setter to compute the values of properties of this class. Other properties are provided a default value in case middle is not set. Now we have made an instance of this class called result variable. We can access the getter of middle by accessing the value of middle property by using dot syntax as shown. As you can see, if we write result dot middle, we get the middle coordinates as returned by the getter of the middle property. Now if we assign a new value to the middle property of this instance of sample1 class and then try to access number 1 and number 2 properties of this instance, we observe that they are not the default values anymore. Instead, they are computed in the setter of this middle property. Property observer. Property observer observes and responds to changes in a property's value. They are called every time a property's value is set. You can add property observer to a stored property except lazy stored properties. Will set and did set are the two property observers provided in Swift. Will set is called just before the value is stored and did set is called immediately after the new value is stored. We can add property observers to inherited properties by using method overriding. When a property is set in initialization, will set and did set observers are not called for it. For example, in this class called observe, we have shown property observers for the counter property. As you can see, every time you set counter to a value, will set and did set observers are called and they print their respective statements, as you can notice in the console. Methods. Methods are functions that are associated with a particular type. Classes, structures, and enumerations can have methods which encapsulate specific tasks and functionality. In Objective-C, classes are the only types that can define methods, but in Swift, you can choose to define a method for a class, structure, or enumeration. Instance methods are the functions that belong to instances of a particular class, structure, or enumeration. They have exactly same syntax as functions. Instance methods have implicit access to all other instance methods and properties of that type. Every instance of a type has an implicit property called self, which can be used to refer to current instance within its own instance methods. Methods of a type are also accessed by using dot syntax similar to that used for accessing properties. For example, here we have defined a class called interest with properties p, r, t, and I, and the method. So this is the initializer of this class, which initializes the values of p, r, and t. Method calculate interest calculates the interest for p, r, and t and assigns the result to a property I. We can create an instance of this interest class by using an initializer with parameters pass as shown. Now we can call the method to calculate interest by using dot syntax for this instance, and then print the value of variable I as shown. So as we can see, we get value 6. Swift functions describe both local and global declarations for their variables. Similarly, Swift methods naming conventions also resemble as that of Objective-C, but the characteristics of global and local parameter names are different for functions and methods. Swift provides flexibility in methods by declaring first parameter name as local parameter name and remaining as global parameter names. So in this case, number 1 is local and number 2 is global by default. You can make first parameter as global 2 by using a hash sign just before the parameter name as shown in this case. Here both parameter names are global. Subscripts. Classes, structures, and enumerations can define subscripts, which are shortcuts for accessing the member elements of a collection, list, or sequence. We use subscripts to set and retrieve values by index without needing separate methods for setting and retrieval. You can define multiple subscripts for a single type. Subscripts enable you to query instance of a type by writing one or more values in square brackets after the instance name. Subscript definitions are written with subscript keyword and one or more input parameters with return type. Subscripts can take any number of input parameters, and these input parameters can be of any type. Subscripts can also return any type. Subscripts can use variadic parameters, but they cannot use in-out parameters or provide default parameter values. A class or a structure can provide as many subscript implementations as it needs. An appropriate subscript will be inferred based on the types of values that are contained within subscript brackets. The definition of multiple subscripts is known as subscript overloading. For example, in this case, we have defined a subscript for a struct. Subscript in this case returns a value which is sum of the count property of the struct and the index which is provided in square brackets. Now we have defined an instance of this struct called division with value for count set to 100. Now if you print division with subscript 9, we get 109, which is sum of the count and the index provided. Inheritance. A class can inherit methods, properties, and other characteristics from another class. When one class inherits from another class, the inheriting class is known as subclass, and the class it inherits from is known as superclass or base class. The act of basing a new class on an existing class is defined as subclass. To define a subclass, colon is used before the base class name as shown. For example, in this case, we have defined a base class called game with properties, players, and fields, and an initializer to initialize the properties. Now we have defined another class called football, which is inheriting from the class game. Football can now access the properties of game class and can also define its own properties, just like goals is defined here. Self is used to access properties of this instance, and super keyword is used to access methods and properties from base class. So in the initializer for football classes, we have called initializer of base class name game by using super dot init. So to check if the properties of games are inherited by football class, we have defined a variable called foo of football type, and trying to access field property which should be inherited in the football class from game class prints the value for field as expected. Accessing the superclass instance methods, properties, and subscripts provide a concept of overriding. Override keyword is used to override the methods declared in superclass. Super keyword is used to access methods, properties, and subscripts declared in the superclass. Swift allows you to override properties, to customize your own getter setters, or to write your own property observer. Final keyword is used to prevent overriding, that is, if a class is declared final, then its properties, methods, and other functionalities are also final by default and hence cannot be overridden. That's it in this video. In next video, we will learn about initialization, deinitialization, and automatic reference counting in Swift programming. Thanks for watching.